It is 2:30. We still have some people joining in, coming in right now, so we'll allow them calling in, but we will go ahead and get started. So appreciate everybody that's got on so far. My name's Jamie McCutcheon. I will not going to keep video on long, but I will at least for the start talk to you so you know who's talking to you. So I am the founder of Rymar Water Works. Just quickly about me, I'm a 1992 grad of Clemson in civil engineering. I founded CCAD Engineering, which is a site planning, land development engineering company back in '99, and was an active engineer up until about a year ago, just over a year ago. In 2013, I invented the Marley Float skimmer and started manufacturing it. I am a licensed professional engineer, South Carolina, North Carolina, and Georgia. So I say all that just to let you know, for many of you that are on here, I've done what you do for most of my career. And hopefully you're going to find this very educational. We're going to focus on a lot of technical items. Please do use the chat or Q&A as we go through here to ask questions. We're going to probably have maybe 70 to 100 people if everybody that signed up gets on. So if you do have a question, you can unmute and ask that. We will try to have some time at the end for questions as well. So with that, I am going to cut my video off so you can just kind of focus on the presentations as we go. So today we're going to talk about introduction to skimmers and floating outlets. And we're going to look at basics of skimmer design basin. We have a focus today for Indiana and Texas standards. That's two markets that we've just seen coming on in the last year. And so this is a little bit geared towards that, but most of it applies just about anywhere. Then we're going to turn from the sediment basin standards to talking about using skimmers for post-construction. We'll go through a little quick case study about why you might want to do that. Then we're going to talk about if you do want to do that, how do you model that skimmer in HydroFlow or HydroCAD? And then the final thing is going to be talking about our new water quality filter and why you might want to consider filtration-based design versus typical volume-based designs for water quality. So most of you have seen one of these in the field. It's a perforated riser or standpipe. Most of them have, may have perforations through the riser, but a lot of times it's just a hole at the bottom. And, unfortunately, it's pulling in a lot of mud because that's where the mud tends to settle. This basin's got a lot of sediment in it. And imagine if you look at the front of that stone check dam, it's probably pretty much silted in. So skimmers have been around for quite a while now. Like I said, some states have been enforcing them for maybe 15 to 20 years. Others are just now coming on board. But the main thing with the skimmers, it floats on or near the surface of the basin and drains the basin from the top down. So it meets the surface dewatering component of your construction general permit. And they've actually shown to be very effective. So it makes sense. You release the cleaner water at the top of the water column, allow more time for the mud to settle, and then slowly drain the basin down to the bottom. So there are a number of skimmers on the market. The Faircloth skimmer was one of the first commercial versions. Erosion Supply or ESC skimmer is very similar to the Faircloth. You've got the Marley Float, which obviously looks a little bit different than most of the others, and then the IAS skimmer. And there are some skimmers that can be made by the contractors. So there are three basic fundamentals of sediment basin design. And so the first one is basin volume. And what I've seen over the time here, we sell skimmers in a number of different states. 1,800 to 3,600 cubic feet per acre seems to be the norm. Indiana requires 5,600 cubic feet per acre. So for 5 acres, that'd be a 28,000 cubic foot volume. Texas prefers that you calculate the volume based on a 2-year, 24-hour storm, or allows 3,600 cubic feet per acre. And actually, if you get into the design, it's the lesser of the two. So if you do have a 2-year, 24-hour storm that produces less than 3,600 cubic feet per acre, you could use that. In Indiana, similar, it actually allows you to calculate the volume based on the 1-year, 24-hour storm. And so in a lot of cases, that volume is going to be less than that 5,600 cubic feet per acre. So if you're trying to save area on your site, which we all fight with trying to, have room for these sediment basins and detention ponds, it may be worth calculating in those areas. But most other states just have a standard of 1,800 or 3,600 cubic feet. Some areas, Ohio, Indiana, and Texas among them, also require basins to have a permanent pool or sediment storage volume that is not drained by the skimmer, and you do not include this volume when you size the skimmer. So the second fundamental is dewatering time. So basins are going to work by allowing time for sediment to settle to the bottom. Again, surface dewatering and giving more time to get the sediment to settle out. The time required is going to vary based on the soil type. Obviously, sands are going to settle really quick. So if you're in a very sandy area, that's fine to maybe let it drain a little faster. However, silts and clays take much longer, if they settle at all. It's different getting the mass out versus the color out. So what we see across the country is 2 to 5 days is probably the most common standard we see. Indiana is 48 to 72 hours, and Texas is a minimum of 36 hours. And actually, I forgot to change this. I actually found where there is a max of 72, so it's 36 to 72 hours in Texas. And use your engineering judgment to determine the need for extended times for soil types versus the frequency of rain events. We're based in South Carolina, and so it's not uncommon to get that thunderstorm every afternoon in the summer. So you might want to drain the basin a little faster so it doesn't overtop. So once you have the basin volume and you have the dewatering time, the third is going to be the flow rate. So the flow rate is going to be basically determined by the basin volume divided by the dewatering time. And you're going to use the minimum dewatering time for the maximum flow rate and vice versa. So for example, our 28,000 cubic feet for our 5-acre site in Indiana, would be 14,000 cubic feet per day if you drain it in 2 days minimum time of 0.16 CFS. Or if you did a 3-day, your flow rate would go down to 0.11. So one thing to point out, especially when you have that broader 2 to 5 day range, so 72-hour range, a lower flow rate will often result in a smaller and typically less expensive skimmer. So real quick, I want to ask the audience here to participate in a poll. So you should see a poll pop up about where are you located. And if you would really quickly, got a lot to cover today, so I'm going to ask you to punch that in. So cool. Looks like we actually do have a good number of participants from Indiana and Texas. We're excited about that. Appreciate the folks in Ohio and South Carolina. So here's the poll. We'll share that with you real quick. See where everybody's from, but we've got a wide variety on today, which is really nice. So since we do have folks from Indiana and Texas, we're going to talk about the state standards there. So the standards in Indiana are fairly new. Actually, these are from IDEM, their state department, and they still have draft on them. So that's how new they are. So again, the dewatering zone for sediment basins is 5,600 cubic feet or the 1-year 24-hour storm. And you do have this sediment storage zone that is below the invert of your skimmer, and it's 1,000 cubic feet per disturbed acre. That's also in the text for sediment basins, both of those. And then the dewatering zone should drain no less than 48 and no longer than 72. So a 24-hour range is actually pretty tight for these. We've seen a lot of places where you have a 72-hour range, but that's what IDEM has decided they want to go with right now. They do require that you dewater from the surface, so you can use floating outlets, pumps, or other things. And one thing to point out is you do need to make alternatives for freezing time periods. If your construction site is going to be under construction in that probably November to February range, folks in Indiana know this better than myself, you need to probably have a way to drain that basin if the skimmer does freeze in the pond. And then finally, like we said, the minimum 1,000 cubic feet, and again, they point out should not be included in the dewatering storage volume. Apologize, I'm getting over some allergies, so may cough a time or two, but try to keep that to a minimum. So your temporary sediment basin design sheet, you're going to have this area here. You got your total area, total disturbed area. Those correlate with your dewatering zone and your sediment storage volumes. One thing here on dewatering time, we recommend establishing a range of time for dewatering. The reason for that is you're often going to get a contractor that says you have a you have a different skimmer that they want to use, and can we use it? Well, maybe, maybe not. Depends on if it still meets the flow rate required. So if you establish that range, it gives them more likelihood that they can do that. I'm not going to go through this entire basin data sheet. I'm sure most of you are familiar with that. I just want to kind of focus on the things that are skimmer related for this webinar today. And we are getting a couple of questions. I'm going to try to glance at those from time to time, and try not to take up too much time doing that. And I'll also answer questions at the end. So IDEM has released draft standards for floating skimmers. It's section 708.03. They go into more detail regarding the specifics on skimmers, and it really is the same thing that we've already gone over. So here, kind of at the bottom, you see the floating outlets, unlikely to be used November to March. We're going to jump over real quick to Texas sediment basin standards. So they're similar. Again, the storage provides storage for the 2-year 24-hour storm or the 3,600 cubic feet per acre. One thing to note is the Texas TCEQ construction general permit just went into effect last year, this time, March 5th of 23, and it has very specific requirements for sediment basins. We're just now really starting to see more skimmers in Texas, but these regulations have been in the construction general permit since 2013. I believe March of 2013 is when they first went into effect. And so it's taken, 10 years or so to kind of get around to enforcing these things. And then they do have in the CGP that unless infeasible, you need to use outlet structures that withdraw water from the surface. So a lot of the details in certain cities and counties in Texas still show the riser structure in their standard detail, but they're starting to catch up with updating their standards to include skimmers. So north central Texas is where the stormwater manual comes from. This includes design requirements for sediment basins. Again, has the kind of the same things in here we've gone over. One thing they do point out with skimmers is that the flow rate needed to discharge the storm basin, you need to select a skimmer based on the flow rate, not the skimmer size. And we're going to talk about that in just a second. Again, you've got a minimum dewatering time of 36 hours. And here we have, at least whenever possible, less than 72. They don't say a shall there. So, if you end up going slightly over 72, looks like that's okay. Your primary outlet is going to be the 25-year 24-hour storm. And then again, withdraw water from the surface unless infeasible, and base the discharge rates on the skimmers itself. Most skimmers have third-party testing to confirm their flow rates, and we recommend you use that rather than the orifice equations. Again, there is a design form for North Central Texas, has the general same information. Oops, sorry, jump through that. And it does say the lesser of 3,600 cubic feet or 2-year 24-hour storm. So the text is a little bit different than that, but since they've got this design form in there, I'd say you're safe to go with that in most cases. Then I'll just quickly want to run through some state sediment basin standards, just to kind of give you a feel for how it does differ across the country. South Carolina, where we're based, again, the volume is 3,600 cubic feet for the total area. Texas is the 2-year 24-hour storm or 3,600 cubic feet, plus the 1,000 cubic feet for sediment storage. Indiana is the largest volume required of 5,600 cubic feet plus that 1,000, and then Ohio is 1,800 cubic feet plus the 1,000. So you can see, pretty big differences when you go to your pond requirements for the different states. Some states have requirements for surface area. Texas has a minimum length to width ratio they want to see. Indiana and Ohio just have a preferred or maximum depth. Principal spillway is typically going to be your riser structure and your skimmer together. So it's going to be anywhere from the 10 to 25-year storm for that. And emergency spillway, and that's not correct, that should be 100-year. 100-year to 25-year storm. Where skimmers are required, a lot of times it's 10 acres or more. But typically what we see in forest is if you have a sediment basin and not a sediment trap with a rock outlet, they're going to want you to use a skimmer for that. And then again, main one down here, dewatering time, that 2 to 5 days in a lot of places. Other places have a narrower window of 36 to 72 or 48 to 72, like Texas or Indiana. And Ohio actually allows 2 to 7 days. So one more thing I want to point out about skimmers is that a skimmer does vary as far as the flow rate. And so this chart came from TRI Environmental. They did some testing for Georgia, and they tested 3 different types of skimmers. They tested a bunch of orifice sizes in those, but we'll focus here on the 3-inch skimmers. And so their test tank was 4 feet deep, so it goes 0 to 4 feet. And you'll see down here, 2 of the skimmers had a very similar flow rate, about 37 GPM. One skimmer was nearly double that at 70 GPM. All 3 skimmers had an increase in flow, about 25% increase in flow rate from 1 foot to 4 feet. Pretty steady progression through there. And again, 2 skimmers were close, and they're just below or just above 50 GPM. But again, the other was nearly double at 90 GPM. So the point here is that if you simply spec 3-inch skimmer and don't give any other information, you're not sure what you're going to get, because manufacturers do have different flow rates. All right, and I do have, looks like Lynn's trying to answer your chat questions, so I'm gonna let her take care of those, and then we'll pick up at the end with any other questions. So, all right, one thing we want to point out today, because this is a Rymar webinar, is we have a design tool that we've developed working with multiple states, and really kind of the intent here is to help you as engineer consultant get through the permit process a little faster. So here's our, we have our date, project name, location, company name, engineer, basin description. And then this is the one for our permanent pools. We have a required sediment storage. That's typically your disturbed acreage and that 1,000 cubic feet per acre. So if you had 5 disturbed acres going to this basin, it would need 5,000 cubic feet of sediment storage below the invert of the skimmer. And then you're going to have your required dewatering volume, which in this case, let's assume 7 total acres, 5 disturbed, but 7 total going to the basin. And if it's in Indiana, it's 5,600 cubic feet per acre. So that's 39.2. And so that is what your required dewatering volume should be based on. You're going to put in your maximum time to drain and minimum time to drain. And then you're going to put in your pond information. So your pond depth is going to be whatever depth is needed to meet that required dewatering volume. So if you've got a pond that's, let's say it's 8 feet deep because it's going to be your detention pond post-construction, you would not put 8 feet deep in here if you don't need that for your dewatering volume. So whatever pond depth meets your dewatering volume, and then your top length and width and your bottom length and width. Now, I realize that there are very, very few square or rectangular ponds, so just adjust these numbers as needed using your engineering judgment. It's going to calculate a pond volume for you. Don't spend all day trying to get this to exactly that same number. We typically recommend try to get within about 5% of your required volume, because again, you're working on a range of time here. When you do that, our handy dandy tool is going to calculate the flow for each skimmer with each orifice configuration. And then down here at the bottom of the page, it's got a skimmer report page tab. Click on that, and it's going to take you to a nice, neat 8.5 by 11 for inclusion in your SWIP or on your plans. The top section is going to have that required pond volume check. So really quickly, your reviewers can see that, hey, we've met this. I know we had a lot of people from Ohio. Depending on your location in Ohio, this is a pet peeve of some reviewers there, if they size the skimmer on the total pond volume. Now, that total pond volume may be 100,000 cubic feet. Well, if that's the case, you drain that 39,000 way too fast. So that's why you want to base that. We tell you what your minimum flow rate is and your maximum flow rate is based on that pond volume. And then because it is our tool, it'll give you the drawdown time for each of our skimmers with each orifice configuration. and tell you which one here met your time frame that you established. So if you've got say a 2 to 5 day range, you may have 5 or 6 skimmers available here. And then as engineer, you can pick which one you want. Do you want to go with, in this case, the 4 inch that drains the pond a little faster, closer to that 48 hours? Or do you want to go with the 3 inch with a 3 inch orifice? That's getting close to that maximum time, but it's going to be a little less expensive for the contractor. Up to you as engineer, which one you prefer. We have some standard details on our website available as well. We have 4. This one is our standard temporary basins that doesn't have a riser structure, and it's a dry basin. This one is our more typical, going to be a post-construction basins, or at least it has a riser and the skimmer. It also has a permanent pool. So if you look at this, there's a chart here that'll tell you the minimum length to width ratio. Now you can edit this as needed. Like it's here, I've got 2 to 1, and in Texas, that's 4 to 1. Maximum length width ratio. Here I've got 6 to 1. Actually, in Texas, they prefer it up to 10 to 1. So you can change this as needed for your location. Very important here, put in your minimum and maximum dewatering time. If you plug that in now and you get that approved during your review, it makes it much easier if you need to swap out skimmers or make a change. Again, you just want to make sure you meet your sediment storage so your provided is equal or more than you're required. Your dewatering volume, typically your provided is going to be greater than you're required. And then standard features, your drainage area, disturbed area, your flow rate for whichever storm events required for your area, surface area, bottom of basin, your outlet inverts, that's your main pipe out, the barrel pipe size, that's your pipe going through your dam, top of riser, emergency spillway, and here we get to the skimmer information. So you got your skimmer size, skimmer orifice diameter. It is our tool, so I'm going to plug Marley in here for you, or Rymar. Change that if needed. Is an equal allowed, yes or no? Most of the time that's going to be yes. There are going to be some times when it's no. If you have some specific requirements that you have to meet a very tight flow rate range, you may say, nope, you have to use the one I spec'd. And then here again, specify your minimum and maximum flow rate based on your minimum and maximum time. If you do this, it typically makes it easier when you do have contractors make requests to confirm if the skimmer they want to use complies with the design requirements that you had to meet. And then we have here our skimmer detail. I know this chart's hard to read, but what this is the flow rate for the skimmer and each orifice configuration. Each of our skimmers have what we call an orifice plate. It's basically a rubber plate that goes inside the skimmer. We'll have a little more on that later as far as how that works, but it makes it really easy for contractors to get the size right. Some other skimmers have a disc that is required to be cut by the contractor to within 1/10 of an inch. The challenge there is if you do move that skimmer to another pond, it may not need the exact size, where with the standard orifices here, they can change it to a variety of sizes for or flow rates for different ponds. Other thing we point out is our flexible coupling here. It's similar to like a Fernco type coupling. It's just 2 pipe worm clamps on each end, so very simple to install. And then we get asked a lot of times, how long does this barrel pipe need to be? Connecting the skimmer to the outlet structure. We recommend a minimum of 1.4 times the height of your riser structure. That allows the skimmer to basically get up at a 45-degree angle to get to the top of the riser. We also generally say a minimum of 8 feet. If your riser structure is only 2 feet tall, 3 feet tall, you want a little more than like 4 or 5 feet of pipe here. It's just going to function better. And then we also show a 12-inch deep depression here. The reason for that is if it is going to be a dry basin, you want the skimmer to come all the way down and drain that basin completely and limit the area of standing water. So real quick, I'm going to launch one more poll here. Like to know, what you do in your profession. Are you a consultant, inspector, contractor? Our MS4 regulatory folks here, or any developers. So looks like vast majority of engineers. So that's good to see. We do have a few MS4, regulatory folks. So I will not talk bad about you. At least I'll do my best. And then I'm just kidding. We love our MS4 folks, and we'll focus on the engineers. So in that poll, share that real quick. All right. So we had about 74% answer, and 67% were engineers. So, all right. So going forward, a couple of quick pictures. This is a skimmer in a pond that's brand new, right? They just tracked the sides in. Obviously, it's rained a little bit, but you can still see where they tracked the sides. They got their baffles up. Looks like they probably put the baffles in after the rain because there's no staining on the barrels yet, on the baffles yet. Thing I like to point out here is this pad for the skimmer. If it's a dry basin, we often do call out for having some sort of a stone pad. Um, in this case, we would prefer contractor have dug that out and lower that skimmer because, as you can see, when it does rain, there's going to be 8 inches or so of water that's going to stand in that pond pretty much at all times unless it either evaporates or infiltrates. And with this red clay soil, I doubt there's a lot of infiltration. So just something to be aware of that. This is probably our worst example of an installation. I believe this actually came from an inspector in Ohio. If you look here, there's no flexible coupling. The pipe's about 6 inches long. Not sure what the contractor was thinking. Thankfully, they do have the stone berm here. Typically, with skimmers, you really don't need that. And if you notice here on the right side, they left the valve open, so there's hardly any water going through the skimmer anyway. It's all bypassing. So, I didn't see but a couple of contractors on here, so I won't talk too bad about contractors either. But sometimes things do happen in the field. And then we have seen this. This is one of our skimmers was put in upside down and with way too short a pipe. So I guess the good news is it's still going to drain most of the pond because it can't float up. But again, we try to make it very simple for installation to avoid errors, but time to time they do happen. Then lastly, this is a project that actually was an engineering project of mine several years ago. This skimmer had vegetation growing out of it. It also needed to have some sediment removed. See, the pipe here was raised, but if you see vegetation growing out of the skimmer, there's probably a problem. This skimmer wouldn't flow. It had like a 10-inch root ball inside of it that was restricting flow, so the pond was staying wet much longer than it needed to because it just couldn't get any water out. So that's most of our during construction talk. Again, if you have any questions, please put those in the chat and we'll hopefully have some time at the end to go over those. If you have a major question you have to have answered, unmute and ask me. I don't mind. We've got about 60 people on here, but if we only have a couple of those, that'll be okay. But we're going to pivot now and we're going to start talking about permanent use of skimmers. So real quick, just to help me out, I'm going to launch one more poll. Have you ever considered using a skimmer for permanent use? I am thrilled to see that some of you have. That's awesome. Glad to see that. Majority is no, which is what I would expect. And then some of you have thought about it but haven't done it. So that's awesome. So I'm going to end the poll there and share those results. So about half of you said nope, never thought of it. Some said 22% said considered and 24% said yes. So cool. So we'll talk about permanent use of skimmers. So this is our typical dry basin, right? You got the skimmer's been taken off. You got a low flow orifice of some sort installed to release that first flush volume for water quality. And you got some sort of guard down here to try to keep that thing from getting clogged best you can. Filter stone, perforated pipe, trash rack, whatever it may be, depending on it. But this may be exaggerated model. All the sediment is coming downhill down to this location. So with a skimmer, basins are going to rely upon the natural settling of sediment particles as they travel from the inlet to the outlet structure. So you got our sediment coming in, and the idea is we have enough time for that sediment to get to the bottom and not get out. However, with that inlet at the bottom, that's harder to do. Skimmer is going to release that cleaner water from the surface. it's now widely accepted to do that in construction, right? So we've been doing this in some areas for 15 or 20 years, and skimmers actually, we can all complain about the EPA, but this skimmers are one of the things, the surface dewatering, that's actually a very cost-effective, high-benefit requirement. So why would we take the skimmer off post-construction and start sucking the mud off the bottom again? So it just seems to make sense to consider releasing that cleaner water from the surface for post-construction. So this is a little quick case study. So we had a site in South Carolina that was a mess. It had been severely overgrown. Contractor went in and cleaned it up, and this is after the first cleanup. You can see it's just holding water. See some orifices here. We did some investigation, and we found out that there is a 2-inch orifice 6 feet below the now bottom of the pond. So 6 feet of muck had accumulated in this pond and needed to be cleaned out. So we got permission from the county to modify the pond and put in a skimmer as a pilot project. So to do that, we had to monitor the skimmer for the first 12 months. And so this picture here is a good example. We now have a skimmer in, okay? The skimmer had a 4-inch orifice, which, double the size of that 2-inch, so it's less prone to clog, but it's also much easier to get to. And skimmer worked really well for about the first year. Just after the first year, the owner now decided they were going to do some maintenance, and they went out and cut all the vegetation on the side of the pond. And before they could get it out, it rained and it washed all the clippings down in the bottom of the pond. And this was the result. So we had a 5-inch rain, just flushed everything down. But you can see our skimmer here kind of buried in the muck and debris did actually drain the pond. You can imagine if there was a 2-inch orifice down here with all that junk, very likely to have been clogged. It's kind of hard to tell. This is a 12-foot riser. There's 6-foot sections. And remember, there's a 6-foot section below because all this junk has accumulated in this basin. So if you had a 2-inch orifice here, it'd have been a really hazardous situation to try to get to. Honestly, would have required scuba gear to try to get it unclogged. So just a good example of how a skimmer can help with maintenance. Typically you'd have a rope tied to the skimmer. So if it did clog, you just pull it over to the side, shake it off, it'll start draining again. So much easier to clean out than a low flow orifice at the bottom of the pond that's totally clogged. So if we're going to consider using a skimmer post-construction, how do we model that, right? We've got to now put that into our detention basin design model and show our regulatory folks that, yes, we still meet our requirements. So we're going to talk about advanced skimmer modeling for hydroflow. Now that hydroflow is part of Autodesk, that seems to be the most popular hydrology software, but this will generally apply to most hydrology softwares. At least you'll kind of get the intent. So this is a site we did. It was actually in the city of Greenville, South Carolina. Greenville is unique in that they require quantity control during construction. So this was our model. We had our existing site and our proposed. The site was about 5.5 acres. It was about 3.4 acres up here that wasn't being disturbed, but it was coming down to our study point. And then we had 2.25 acres that we're disturbing. We're putting in a little sediment basin, and this is flowing down to a road. Actually, it was going to flow across the road, so we wanted to maintain our peak just so we didn't create liability. So again, a pre-development, 5.5 acres. They occurred number 59. That was a wooded site, Class B soils. Time of concentration was 18.5 minutes. In post-development, the portion disturbed was 2.25 acres. Occurred number is 86 for bare earth clay in our area. Time of concentration down to 7 minutes. So when you build your pond, you need a place to enter your skimmer flow data. So when you do your stage, you want to build in the stage for later being able to enter your flow. So here we have 0, 0.1, 0.3, and then a 1/2 foot up to 4 feet. That's going to correlate with the testing data for flow rate on our skimmers. So you're just going to be able to plug that in later. So then when you get to build your outlet structure, you've got your barrel. That's your 18-inch pipe going out. Complicated little structure for a small pond. So you've got a 6-inch orifice that's 1.75 feet above the bottom. got a riser structure that's 3.6 feet tall and has a 1 foot rectangular weir 3 feet above the bottom. And then the secret sauce to this is this user-defined column. So here is where you're going to enter the flow rate for the skimmer. Again, you built your stages, so you can plug that in and build in that flow rate curve to HydroFlow. Now, HydroFlow will interpolate between the stages. You don't have to, every half a foot or even a foot is okay. If your basin's over 4 feet deep, we have a couple of recommendations. So one, you can just use the flow rate at 4 foot of depth. It's not going up that much more there. If it's 5 feet or maybe 6 feet, that's probably fine. If you want to extrapolate it based on these last 3 data points, that's fine. If you want to get really detailed, you can go back to our design tool we talked about. You can put in your pond depth to what it actually is, not just what you're doing for your skimmer. It's going to break the water level into 20 increments, and then it's going to give you the flow rate, and you just use the spreadsheet and go across to whatever skimmer and orifice configuration you're using, but it'll give you the flow rate at each incremental depth. And then you would use these increments in your HydroFlow stage storage or something pretty close to them. What you're going to find is they don't change a lot from when, again, the bigger skimmers have about a 25% increase in flow from 0 to 4 feet. Smaller skimmers, you see less of that. But this will give you that exact, you can go out to 4 or 5 decimal places if you need to for your flow rate. So that's how we recommend if you really have a deeper pond to get more accurate flow data. So then you're going to see your schematic of your outlet structure look like this. So again, normally you'd have a low flow orifice down here, right? You'd have a 2 or 3 inch hole that you're using for your low flow. You're not going to have that. You're going to have your user defined take that place, your 6-inch orifice, your rectangular weir, top of your riser. But if you look at your stage discharge curve, here's your skimmer flow. So that's your user defined kicking in here. I know that green line's a little hard to see, but we've got the green line here. That's your skimmer flow, which is a very small percentage of that total flow. Total flow is getting up 3 to 5 CFS. That skimmer is like at 0.1, 0.2 CFS. And then your table here is going to show that your user defined and your total flow are basically the same until the other orifices kick in. So we said here at 1.75 feet, our 6-inch orifice. So now our total outflow is more than that 0.32. It includes that 6-inch orifice as well, and so on. Hopefully that makes sense. If there is a more detailed tutorial video on our website or our YouTube channel, both for sediment basin design and for HydroFlow. And then real quick too, we're going to touch on HydroCAD. HydroCAD is a software that's really similar to HydroFlow. The one difference in HydroCAD is that it's a much smaller company and it has incorporated a lot of proprietary products. And so here with HydroCAD, the main difference is when you build your outlet structure, you don't have to build in the stage storage for each data point anymore. They have these things called special and user defined outlets. And if you click on that, it takes you to a folder that has multiple folders of a variety of proprietary products. One is the Marley Float skimmer. So you just go into there and you pick which Marley float you want to try, and it plugs in the flow rate for you up to 4 feet. It has this neat little extrapolate button. So instead of having to go back to our tool and put it in, you can tell it to extrapolate. It'll use the last 3 data points and extrapolate the flow out. If you had huge pond, you needed 2 or 3 skimmers, you can do a discharge multiplier for that. And so just makes it a little bit quicker, kind of avoids the typos that you have with the potential with HydroFlow. All right, so last thing here we're going to talk about is we're really excited about this too, and hopefully this makes a lot of sense not only to our engineering participants today, but also for those in the MS4s. I'd love to get some feedback from you, and you'll see why here in just a few minutes. So we're going to talk about advanced skimmer modeling for filtration-based water quality. All right, so what are we talking about here? So we've been doing research now for a couple of years to put a filter around our skimmer. And so this goes back to that same pond that we have been using kind of as our guinea pig, that one that we first put a skimmer in and did the pilot program. And we came up with this filtration system that's a two-stage system. The outer stage, and it's kind of hard to see here, this is basically a turbidity curtain, but it's a flow-through curtain. So it's got a basically a screen like a Mirify 402 polyethylene fabric, filter fabric on the outside here, the woven material. And then here on the inside, we have this non-woven fabric. So this is a material called Adsorbate. The version we use actually has an antimicrobial treatment on it, so it has some benefit for bacteria. It does a great job of absorbing hydrocarbons and has proven to be very effective with TSS. They do have some benefit with metals, and you're going to get out a lot of the particulate phosphorus and nitrogen. We don't know if it's going to do anything for the dissolved phosphorus or nitrogen, but at least you're going to get that particulate portion out. And so we've been field testing this now for about 2 years. It's shown it's gone really well. So you can see, it's kind of hard to see in this picture, but you see the turbidity of the water in the basin is higher than what's here through the skimmer. You can definitely see there's a slight color change here and there. But if you look at the outlets, this is actually the outlet of the pond flowing, and that water is actually pretty clear. I don't know that I would drink it, but it's definitely a lot cleaner than what was coming in. And so we have had this now tested. We did a third-party test. We used TRI Environmental, the same company that did the testing for Georgia, and they confirmed over 90% TSS removal for the skimmer filter combination. There is an ASTM standard out there. It's C1746. ASTM has just recently gotten into establishing standards for stormwater quality, but this is the new one here for sediment retention devices. And we had to test two versions. We tested our 2-inch skimmer, I think, with an 1.5-inch orifice and a 4-inch skimmer. And one thing I want to point out is we tested this to take out the benefit of the pond. So your typical pond is going to have a 4-bay. There's going to be a significant distance from the inlet to the outlet, so you're going to get some settling. You're going to have some benefits of just the travel time, right? Well, in this case, oops, hit the wrong button. This is our inflow with our sediment-laden water. So it's really like 1.5 feet, 2 feet here between the inflow and our filter. And so we're using the skimmer to pull this flow through the two stages of our filter. The filter is 30 inches deep or 36 inches deep, so it's 3 feet, and it's open on the bottom. And so if the sediment does settle down to 3 feet and you get some flow coming from below, the flow rate is not enough to pull that sediment up 3 feet so it gets discharged. So we're letting gravity do its work. Advantage of that is you're always going to have an open bottom, so you'll never completely blind off or clog up. But you do get the benefit of most of the flow coming through the filter. And so we now have put that version into the pond. So this is actually gives you a pretty good feel. When you saw that trash from the pond, these are really steep side slopes coming in. You can see all this muck, debris floating here. There's I think a 40 or 50 acre drainage area coming to this pond, highly developed, all commercial, and virtually no other stormwater management in that area. And then this is our current skimmer with the commercial version of the filter here. So it's, again, that woven fabric on the outside, non-woven on the inside. And I've got to mention, we do have a time-lapse camera set up, so we monitor this every storm event. We're taking pictures and keeping going. So let's talk about what are the benefits. Let's just look at filtration versus settlement. And so if you have filtration, rather than having to slowly discharge that first flush over 24 hours or more, you can base that flow rate on whatever your filter can handle. That filter is going to treat 100% of runoff from the storms up to the peak rate of the filter. So what happens if it rains 1/4 inch in 6 hours, where you are? How much ponding are you seeing in those detention ponds? How much settlement are you actually getting? Reality is that first flush, if it hadn't rained in a couple of weeks and that's a relatively small rain, could be a hard, quick rain, but a small, it's going to flow in and flow out, right? I mean, we're not really treating that water, although that is our water quality method. And then the other thing is your filtration media can be customized to target specific pollutants of concern. Hey, it's at a gas station or a truck stop and you need hydrocarbons. We've got a industrial site that has does metals. Okay, we got to do something with that. So you have the option to add specific media for specific concerns. So again, the benefits to filtration is, that peak rate. Actually, sorry, duplicate slide. So then let's talk about what's the benefits to using the skimmer with filtration. So first off, we got a benefit just for filtration versus standard settling. Now, if we look at the skimmers with it, well, now your skimmer is going to be used to control the peak rate for that lower storm event. So if you can size the skimmer to handle that 2-year storm event, and that's your first quantity control event, obviously depending on your location, use the skimmer to do that. Okay, the skimmer is going to increase the filter efficiency by withdrawing from the surface where the water's cleaner. So, okay, now our filter is not going to get as dirty because you're going to be trying to pull cleaner water through it, letting the other stuff settle out. And then the skimmer is pretty easy to access, right? You can just pull it to the side, you can get to it, you maintain it, you're not getting in a vault, no confined space entry, that kind of stuff. And so the other thing here, when you use this first, when you use your skimmer to control your peak rate, let's say you do size your skimmer for a 2-year storm, you're now treating all the rainfall up to that 2-year storm event to that higher treatment rate, in our case, over 90% TSS. So you're actually getting, whether it's a tiny storm, it goes through the filter. Up to a 2-year storm, goes through the filter. So you're getting much better treatment. But skimmers with filtration are definitely not the perfect, fit-all example or answer. They're going to be prone to clog over time. You're going to have to do some maintenance. We all understand maintenance is a challenge, and so having to rely on that, that does pose an issue. Your skimmer's got to be durable. We would not recommend use of PVC products for this. Our skimmer happens to be HDPE. It was designed whenever I invented it to be a permanent use product, just because I thought there was advantage to that. And here is probably the biggest challenge: is there are no established standards for basis of design or permitting when you combine a pond and a filter. Most ponds say first flush, slow release, extended detention. Those standards are in there, right? We have very few people that have, or none that I know of, that have standards to combine a filter and a pond. In most cases, this is going to be treated as a MTD, mechanical treatment device or proprietary device. Some places have very strict requirements on those. Some have very little requirements on those. It's going to be based on your area. Interesting question. I got a question. Do people steal skimmers? Haven't really seen many stolen, but I have seen some vandalized. Evidently, they make good targets sometime for people with BB guns or 22s. So let's go through a quick example to kind of demonstrate the benefit of first flush versus filtration-based water quality. So we're going to have a sample site here. We'll say the site's 5 acres. We got a pre-development condition. We're going to call it wooded, curve number of 55, so very low flow coming off. Post-development, we're going to do a shopping center. So we're going to have a commercial going up to 92. So first thing we're going to do is we're going to calculate our pre-development flow rates, right? Came up hypothetical 5-acre site, time of concentration, kind of estimated 48 minutes. Use HydroCAD. We're going to focus on our 2-year storm. 2-year storm events can be 0.72 CFS, then go up to 3 for the 10, 5.4 for the 25, 10.7 for the 100. But again, we're going to focus on the 2-year storm and below for this illustration. So next, what we're going to do, we're going to look at our water quality volume and our post-development flow rates. So we're going to say, okay, it's a 5-acre, fully developed commercial site. Time of concentration is now down to 10 minutes. And we're going to calculate the water quality storm event and the post-development flow rates. So the water quality storm event, in our area, it's 1 inch of runoff, and that's what we're basing on. My understanding is in Texas, it would be 1.5 inches in Texas, and that's determined by the 85th percentile storm, which is also what Indiana uses. I did not find a rainfall runoff amount for Indiana, so if somebody has that, that'd be great to let me know what it is. We got several conferences in Indiana coming up. We want to be accurate. But for this example, let's back up. 1 inch of runoff is 18,150 cubic feet. During trial and error, I came up with 1.73 inch rain event in 24-hour storm, and that would give us our water quality volume. Based on that storm event, we got a 7.23 CFS water quality storm. 2-year went from 0.72 to 19.72, and then on for the 10 and 2500. So traditionally, this is what we used to use when I did this. I'm sure most of you engineers have some similar tool out there. So it is a first flush orifice calculation. Okay, so in this case, we're going to use a dry pond. Got 5 acres. Again, here we have 1 inch for a dry pond. I'm going to hold it for 24 hours. And so what we do is we assume that that entire volume magically, instantaneously, poof, appears in the pond, right? And we know that doesn't happen, but that's what we base it on. And then we're going to drain that volume 24 hours. That gives us a 2.6 inch orifice, or a 0.21 CFS flow rate. So let's do a pond design. So we came up with a hypothetical pond design, got that water quality volume in here. Okay, our bottom of our pond's at 110. We're going up to 113 to reach that 18,150 cubic feet. We get to put in an orifice above that. So in this case, I put a 3-inch orifice to control the 2-year storm, and then an 8-inch orifice was doing the 10-year storm, and the top of the riser was doing 25, and emergency spillway doing the 100. So that's our storm event. Now we've got a peak flow for our water quality at 0.25 CFS. And then it only needs 10,000 cubic feet of volume to run that storm event. Remember, we're required to have 18,000 before we can have another orifice. So we're really only using, 8,000 or 7,500 cubic feet less volume than what we're required to have. 2-year storm, we ran it at a 0.81. Again, it was 0.72. So we maybe, allow a less than a tenth of a CFS increase, maybe not, depending on your location. And here's the storage required for each storm event. So now let's look at the alternative to using the skimmer with a filter and see how that works. So first we got to pick the skimmer. Okay, so this is the flow rate chart. These are ours, so we're going to use that. So our 6-inch skimmer flows at 0.78 CFS. That's our peak flow rate. That's actually taken at a 4-foot depth. So, what we're going to use is going to be a little less than that. So let's try it in our model. Our filters are designed to make sure they keep up with the flow rate of the skimmer. So this filter is never going to compromise the flow rate of the skimmer. We specify for the filter a L1 and L2 for both our inner and outer skirts. If you look at this chart, it'll give you dimensions. What you're going to see on some of the 6-inch and 8-inch and our 8-inch max, when our highest flow rate skimmer, that outer skirt gets pretty long. Okay, our biggest one here is 16 feet this direction, 46 feet this direction. Now, for that skimmer to go in, is probably going to be a pond serving 10, 15, maybe 20 acres. But kind of depends on what your flow rate you're trying to hit. The reason we do that, as the skimmer rises, it's going to get closer to the outlet structure, right? That pipe's coming up. And so we don't want the dimension from the skimmer to here to be more than about 8 feet, because you really don't want more than a 20-foot stick of pipe in here. Don't want to have to add multiple pipes. So that's why we have it designed that way. Kind of assumed it's going to be a large pond and we can go out. So if it's 46 feet total, that's 23 feet in each direction. You probably have that in a lot of ponds. Again, we have our outer skirt is this Mirify 402 woven geotextile, and the inner skirt is the Adsorbate. One thing to point out, it's actually 2 layers and they're slit. And so we found out that although this material is supposed to have a pretty high flow rate, it wasn't getting great flow through it. So we slit it and we offset the slits. And so water kind of goes back and forth, snakes through there. And so we get good contact time on this material. Really helps with the hydrocarbon and other pollutants we're trying to take out. Also have a detail for how to put it in a pond. If you may recall, our previous detail showed the skimmer kind of up against the bank. That was kind of for maintenance. For this, you definitely want to make sure you got room, right? You don't want to put it up against the bank and the filter hitting against the side. So you kind of want to get it out in the open part of the pond. Here's all the information you're going to put in for your pond design. So how does this run? So now we have a our same water quality volume. But in this case, we put our skimmer in here. Our 6-inch skimmer is being used for our water quality and our 2-year storm event. And then we have an 8-inch orifice, and it's 4.8 feet above. And so our numbers come out like this. So our water quality peak flow rate is now 0.7 CFS. Remember, it was 0.25 before. So we've tripled our flow rate for the water quality storm, but it's still below our first quantity event of our 2-year storm. We're only using 7,600 cubic feet. So we've got, over 10,000 cubic feet now available to help with our detention on our 2-year and up storms. 2-year storm is 0.78. We were at 0.81 before. We're still assuming we can have a slight, 0.06 CFS increase for a 2-year storm. And so with that, our storage required is much lower than traditional. So you can see the differences here, really easier to see in percentage. So we've got a 30% reduction in storage required. Now that's based on what was being used in our traditional design. It is much more than that. It's almost 65, 70% less than what's required for our water quality volume, when we do our little spreadsheet calculation. And then 14 to 12% less on the other storm events. So, if any of you have any clients out there that complain when their pond gets smaller, please let me know. Have not found one of those yet. All right, we'll wrap up here. I know we're coming up on the end of our time. Just got a couple more things to go through. So I'm gonna get to the very brief sales portion of our presentation. We are Rymar Waterworks Innovation, so rymarwaterworks.com is our website. We're really proud of our website. We try to make it very useful for engineers. We have a on-demand webinar there. Very likely this one's being recorded, so we'll probably update it with that information. We also have our training series. So now we have our first 4 series uploaded. We've got 4 more coming that are going to include more information about the post-construction modeling and water quality filter. So those should be up here hopefully within the next few weeks, if I can get those done for you. And then the other thing to point out is we have our spec sheet page. And so we have all this included in what we call our engineer spec pack. So it's one download, it's a zip file. So if you go to our website, download that, you're going to have the Marley Scope float skimmer details. You're going to have our Excel design tools. We're going to give you a copy of the test data confirming our flow rates. You're also going to have the sediment basin details we talked about, those 4 different basins. Plus, you then also going to have a separate filter for all your water quality. So you're going to have the water quality basin details. There's a PDF in there, kind of walk you through our recommendations on design. The test data, again, that's to an ASTM standard, third-party certified. So we know a lot of places out there want to see NJCAT, right? That's a big popular one, is NJCAT test data. We're not NJCAT approved. If I have any, I know we've got Indiana folks on here. If any of you are in Indianapolis or doing projects in Indianapolis, they do have a list of allowable post-construction devices. The first requirement to be on that list is NJCAT approval, and we don't have that. So unfortunately, right now, you probably can't use us in Indianapolis. Most other MS4s in Indiana have said, we're fine with considering it. If an engineer wants to use it, we'll definitely do our review on it. Have not said no. But we give you all the test data and supporting information. There's a program out there, some of you may be familiar with, called STEP. It is a national stormwater program. The first standard they're putting together is on trash collection. The second one is on filtration. We are hopeful this summer the filtration standard is going to be out, and STEP is going to replace, maybe slowly, but hopefully replace over time, the NJCAT and Washington Tape and other local standards, because it's been a really thorough process, and ASTM is highly respected for their rigorous process in establishing standards. And so once that becomes accepted, our filter should be on one of the first filtration devices, because we've already done all of our testing per those ASTM standards. So real quickly about our skimmer, it is an HDPE product. So it's HDPE pipe, it's a polyethylene float. All the fittings are either stainless steel or aluminum. It's designed from its initial conception to be part of the permanent outlet structure and just pivots. There's no really moving parts to get stuck or break. We have this debris guard, and so what that does is it keeps any trash, debris, seed and straw on the site, first rain, all the straw comes down, all that outside of there. We take the flow in from below the surface. So in a mild frozen, say 2, 3, 4 inches of ice, our skimmer is going to continue to work. It's not directly on the surface. Now you get a foot of ice, it's locked up. I'm just going to say it's not going to get much flow through there. It's going to freeze. This is our orifice plate here. There's a little quick video at the top. Hopefully that's showing correctly through Zoom, but that's our 4 different sizes for this one skimmer. And you just simply take it out, twist it. We have this little piece here. The technical term is nub for that. So that makes sure the contractor actually gets it centered and it stays in place. But it allows each orifice to be centered perfectly over the outlet. And all of ours have been third party tested to verify drawdown times. Our skimmer, when it first came out, it was a little different design. We did redesign it about 3 years ago. All the weight's at the bottom, so it always stays level. Hopefully no kids are out playing with a skimmer or pushing it down, or, a goose or, whatever, raccoon, using it, or beaver. But it will always come back and stay level. We have custom floats now. Actually, our 6, 8, and our 3 and 4 all have custom floats. Our 6 and 8 have handles in them. These things weigh about 200 pounds, so it makes it easier to carry. Haven't had it requested yet, but we can do custom colors if you really want that. And then we have 6 different sizes. So we have our 2-inch through our standard 8-inch. Our standard 8-inch uses a 6-inch pipe. And then we have what we call our 8-inch with 8-inch pipe. We often refer to that as 8-inch max. That has a flow rate of 1.8 CFS. So most other 8-inch skimmers flow about 0.9 to 1 CFS. So if you do have a huge site that's got needs multiple skimmers, our 8-inch max may be a good solution for you. So that's it. I am going to now see if I can take a quick look at the Q&A and the chat. And if anybody has any questions, feel free to unmute and ask. I know we're right at our time, so I want to be cognizant of everybody's time. You can put your chat in or your email address in the chat, and Lynn will make sure to get you a PDH. You can also email us info@rymarwaterworks.com. We'll send you a PDH certificate. One question says, what is the Ohio spec that points to not having to use this sediment storage volume for the skimmer design? I'd have to find that one in Ohio, but the skimmer does not drain the sediment storage volume. So what we see in Ohio, and we've worked with Ohio EPA, Summit County, City of Columbus, City of Cleveland, and others, they want the skimmer based on the dewatering volume only, and the required dewatering volume, not the full dewatering volume. Let's see. Looks like maybe some of you may have had some issues getting on. Hopefully you were able to join. We are recording this. Actually, I'm going to stop the recording right now.